Hello guys, welcome to my YouTube channel and I hope you can hear me well. Today I'm going to solve a diffusion question and tell you some tips to solve this kind of questions, right? So this is the question, and first of all you have to read the question carefully and get all the data from that and gather them, right? It's going to be very important. Component A gas is produced by component B, a gas at 323 Kelvin and 1 atm, right? These are the system temperatures and pressure, right? Over a solid C. The following reaction takes place at the solid surface. The reaction is like this: C plus 4B produce A gas, right? So it's going to be like this: if four atoms of B come to the metal surface and react with solid C, so this is the metal surface, solid C, one atom of A will be produced, right? One atom of A will be produced. It's like this: four atoms of B, these are B atoms, come to the metal surface, and these are the metal surface, so C solid, and react with C, right? B for B plus C, it will produce one atom of A, so that atom will go up, right? So B and A are gases, C is the solid, right? So, and remember, no solid C will participate for the diffusion, right? Only diffusion will happen in B and A, right? So we can get a relationship about flux of A and flux of B from that. Basically, flux is the rate of production in moles per meter square second, right? This is the flux units. Flux means J, right? We have a unit. And it is a counter diffusion. So counter diffusion means one atom will go down and other atom will go up, right? It's counter diffusion. Flux of B, we can get a relationship. Flux of B is 4 times the flux of A, and it's a counter diffusion. Then we need to add the minus sign, right, to show the direction. So we can get a relationship like this: JB equals 4 times minus 4 times flux of A. This is the first equation we can get, and the reaction is very rapid, so that the partial pressure of B at the metal surface is essentially zero, right? This is the metal surface, so we can name this as 1, and this is the bulk gas phase, this is the metal surface, 1 is metal surface, 2 is bulk gas phase, right? The gases diffuse through film, we can get the information from that. Partial pressure of B, it means at the metal surface, means we can get a data P B1 is 0, essentially 0. The gases diffuse through a film with the thickness L equals 0.625 millimeters. This is the L, and estimate the rate of production. It means the flux of A, right? Flux of A in mole per meter square second. This is in SI units, right? So we need to convert all the data for to SI units and solve the question. Of solid surface at steady state, the composition of bulk gas phase when Z equals to L is 50 moles percent of B, right? So we can get this is a molar fraction, so we can get another data X B2 equals 0.5. in the bulk gas phase mean this one we have only A and B gas, right? A and B gas, no C solids. C solid is in metal surface, right? In the back bulk gas phase, we have only A and B, right? If B, if the partial pressure of B is 50%, and we can get the partial pressure of A, right? Since total mole fraction is 1, since total mole fraction is 1, it XA2 plus XB2 is my 1. So we can get the XA2 value as 0.5. So we need to find the flux of A, right? So we need the mole fraction of A, right? The binary diffusivity D, this is the diffusivity coefficient. It is 20 millimeters squared per second. Finally, we have a clue. You may use the generalized flux model, this equation, for your estimation, right? So we can start to solve the question from this, and we will write it. So since we need to find flux of A, we don't need flux of B, right? Thus we can substitute for J flux of B from this equation, right? We got a relationship, and we can simplify the equation, right? We substitute the value for flux of B, right? So we can simplify this. This is going to be minus 3 of flux of A. It will go to the other side, and so we simplified the equation, and now we need to integrate and solve the equation, right? So this is flux of A is a constant, and this coefficient is constant, CT value is constant, and other parameters are not constant. They are uh, changing with time, changing with the length, right? So we need to simplify the equation for integration. We can move the dz part into this side, and these are constants, right? So this is the variable part. We can integrate this and this, right? This is the length. We can integrate to 1 to 0 to L, right? This is the limit, 0 to L, and the fraction, mole fraction, uh, 1 to 2, right? In metal surface, from metal surface to the bulk gas phase, 1 to 2 means XA2 and XA1, XA1 to XA2, right? And we can get the equation simplified as L and minus D CT ln 3XA XA2 XA1 and divided by 3 divided by this number, right? Now uh, we have a little problem, right? We don't know what is the total concentration. This CT value is unknown, right? And we know all gases these all gases diffusions. Then we can convert CT the total concentration into system pressure and temperature by using ideal gas. Like, right? We assume ideal gas behavior, then we can get the ideal gas law. PV equals nRT. In this case, concentration means moles divided by volume, right? So we can divide by volume RT, and this is this concentration CRT and P. We know we need to find the CT value, right? Total concentration. So we need to right PT. We know the PT value, R value. This is the universal gas constant, and this is the system temperature, right? CT is equal to P over RT. Uh, now all the values are known. XA1 is molar fraction of A in the metal surface, right? Previously we got the PB1 as 0, so pressure is to x values in the PB1 0 means XA1 XB1 is 0 also. So from the total fraction equation, XA1 plus XB1 is 1, so we can get the XA1 value as 1, right? This is 1, and the XB value, XA2 value is 0.5. And we can substitute for D. This is 20 times. We need to convert them into the SI units, right? L is 0.625 centimeters, and R is 8.315, 323 Kelvin. Total pressure is 118 Pascal. In this equation, L value is known, D value is known, PT, R, T, all the values are known. Only unknown value is the flux of A, right? We need to find that. Then we can calculate this. We can calculate this by using a calculator or analytical method, right? We need to substitute, then get the answer, right? Then I got the answer for flux of A as 0.18. It's the first answer, right? So I hope you understand well, and you can do multiple questions like this and practice more questions. Finally, don't forget to subscribe my channel and like to this video. Have a nice day, guys.